All right, probability and predictions. Let's go. All right, I love this stuff. I love it. It's so much fun. Anyways, probabilities and statistics. Good times. Anyways, so first things we got to talk about is outcomes. Outcomes would be just the results. They'll talk about what's the possible outcomes of this. What are the types of outcomes that could happen. That just mean results. So a simple event would be one outcome or a collection of outcomes. So when they say if I roll a dice 3 times, I'm going to get three outcomes. So those would be 3 simple events. One roll of the dice would be one simple event, or 3 simple events. And then probability is the chance of that event happening. And here's some more on that. So probability, if an outcome is equally likely, then the probability of an event's ratio then compares the number of favorable outcomes to the number of possible outcomes. So you could say, since this is written just like a function, so the function of an event or the probability of an event happening would be the number of favorable outcomes to the number of possible outcomes. And we use a lot of, I don't know why we use these, I guess it's just common, but they use a lot of gambling references. Sorry, that's not the best thing to be talking about at school, but just take a dice. You have 6 possible outcomes, and if I want to roll up 2, there's 1 chance out of 6, 1 favorable outcome, so it would be the probability of rolling a 2 would be 1 out of 6. So a probability, we already said that up there, is always between 0 and 1. So if it's below 1, if it's a negative number, or over 1, you did something wrong. Say the closer the probability is to 1, the more likely it is to happen, or certain. If it's all at 1, it's equally likely. So if I needed to roll a 1, 2, or 3, that would be 3 out of 6, or 0.5, so 0.5 or 50%. And then 0 would be impossible to occur, as in there is no possible outcome. A couple more things. So we'd have sample space, would be a set of possible outcomes. And then theoretical probability is what should occur, or what is predicted to occur. So that's like before you actually run the trial or run the event. So like before we roll the dice, it theoretically should have a 1 in 6 chance of rolling a 2. So experimental probability is what actually occurs. And these are just terms that you'll probably see in either the instructions of something or in a word problem. So as I say, theoretical means it could happen, and then experimental is what actually happened. All right, so suppose a cube is rolled. What is the probability of rolling a 4 or a 5? So there are 2 numbers on a cube that are 4 or 5, 4 and 5. Surprise, surprise, spoiler alert. There are 6 possible outcomes, 1 through 6. So that means I would have a probability of rolling a 4 or a 5, number of favorable outcomes over the number of possible outcomes. So I have 2 probable, I have 2 numbers would be my favorable outcomes, and my total ones are possible outcomes are 6 or 1/3. So I could say, you can say it however they want, but the probability of rolling a 4 and a 5 is 1/3 or 33.5%, or 33 1/3%. All right, on your marks, set, go. All right, so suppose a number of cube is rolled. What is the probability of rolling a number that is divisible by 3? All right, so I have 1 through 6 are my possibles. And how many things are divisible by 3? Well, 3 is divisible by 3, and 6 is divisible by 3. So that gives me 2 outcomes, or positive outcomes. It would be 2 over possible would be 6. And that would give me 1/3, or 33 1/3. All right, suppose 2 numbered cubes are rolled. Find the probability of rolling 2 identical numbers. So make a table showing the sample space when rolling 2 numbered cubes. So this is a probability table. Yeah, it's actually a lot less complicated than it looks. So I have 1 through 6 and 1 through 6. And I start out 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So I'm really just matching up the numbers here and writing it down. So that would be a sample space of possible outcomes. And then we're going to, I believe, highlight the ones. So there are 6 outcomes of which you roll 2 identical numbers. There we go. So we could go right down the middle here. There's 1 possible, 2, 3, 4, 5, 6. So we go 6 straight down the angle. So 6 outcomes in which 2 numbers are identical. So the probability of 2 identical numbers, and the total, 6 times 6. So that means I have a total of, wow, what a terrible total of 36. So my identical numbers would be 6 possibles over 36, or 1/6 after you reduce that, or 16 2/3 chance of rolling 2 identical numbers. Your turn, go. All right, so suppose 2 numbered cubes are rolled. Find the probability of 2 numbers whose sum is 8. So there are, whoops. I'm actually going to bounce back to this one. So if we were looking at this one here, if I can get this to erase. Let's erase all this. All right, so which ones of these have a sum of 8? So it means 4 plus 4 would equal 8. 5 plus 3, and the opposite, 3 plus 5. 2 plus 6, and 6 plus 2. And those are all above it. 7, 7, 7, 7, 7, 7, and below. So there's 5 possible outcomes. So that would give me 5 out of 36. So there's 5 possible or positive outcomes over, positive and then possible is 36, and that's what gives me that. Divide those into your calculator, gives you that. All right, your chances of rolling something that is 8. All right, use the table below to determine the experimental probability of it landing on heads for this experiment. That's another one that's always a big deal, is heads or tails. Well, theoretically, it should be 50% chance. But sometimes the experiment doesn't quite come out that way. So heads, it happened 14 times, and tails happened 11 times. Didn't quite come out to 50-50. So the number of times that heads actually occurs was 14, and the number of possible outcomes, as in how many times did they run the trial, was 25. So 14 plus 11 is how we came up with that on this one. So we had 14 out of 25 would be my possible outcome. So that would be 40-something%. Well, 50-something%, my bad, other way. The experimental probability of landing on heads in this case was 14 out of 25, or 56%, which would be different than the theoretical. Theoretically, 50%. Experimental in this case ended up as 56. And, we could talk about basketball. Go. All right, so Brian is shooting baskets with a basketball. He makes 13 and misses 9. What's the experimental probability of Brian making a shot? Well, he makes 13. So my positive outcomes is 13. And my total shots he took would be 13 plus 9. So that would be out of 22. And I'd have to punch that into my calculator. 13 divided by 22 gives me, I get 13 out of 22. Need to change that to math, decimal. Answer decimal, 59%. I get 0.5909, which I would convert to 59%. All right, Miss Newman surveyed her class to see which sport the kids were favoring. 44 preferred football, 28 preferred basketball, 20% soccer, 8% tennis. Out of the 560 students in the entire school, how many would you expect to say they prefer watching basketball? Oh, this is what they like to watch. Watching soccer? Sorry, moving on. All right, so the total number of students is 560. I said that here. So, we have 44, 28, 33, and we say 28% like watching basketball. So we're going to find 28% of 560. We're going to let B be the base, 560, and let P be the percent of 28. Find the percent proportion. So this is something we just did. So we set it up as 50 as base, how many, and then 28 over 100 is my percent. Excuse me. Cross products, simplify, divide by 100. So approximately 156 kids. Now you can't have 0.8% of a student, so we have to round that up to a solid number. So about 157 students say they would prefer watching basketball. Random side note, we're talking about basketball. Basketball starts, at least for me right now, the NBA starts tonight. Warrior three-peat, here we come! That's my prediction. Moving on. The students in art class surveyed... Oh, it's your turn, bye. The students in art class surveyed of their favorite color, 32% blue, 29% red, 23% yellow, 16% green. Out of the 450 students in the entire school, how many would you expect to say they prefer red? All right, so red, 29% like red. So that would be, and there's 450 total. So 450 total. So I need to know how many. I'm just going to put N out of 450 students equals 29 over 100. We're going to cross products. We give me 100N equals, punch that one in, 29 times 450. Ooh, wow, nice number. 13,050. And then divide by 100. Divide by 100. So we just moved the decimal point over 2. Be 13050, which I would round up to 131.